Hey guys, welcome back to my channel, and today we're going to be talking about limit laws. So limit laws, just before I introduce it, I'm just going to write it down. So limit laws are basically just a way, like laws, different types of laws that are used to calculate limits. And there are several ones we're going to learn today, and we're going to first run the sum law. So in this video, we're just going to list the different laws, and in the next video, I'm actually going to do some problems so that they're separate, and that way you can watch both videos and get an understanding of both. So the sum law is the first one. So let's say we have two different functions, f of x and g of x, and let's say we're given a situation where we have f of x, all right, plus g of x, right? So now in this situation, you're like wondering, oh, what am I supposed to do? Like we have two different functions. So in limits, it's actually very easy. You're basically just going to separate them. So you're going to take the limit of the first function, which is x of a f of x, plus the limit of g of x, basically. And it's actually pretty easy when you see this in terms of numbers. It's basically just plugging an a for the values of x that are in the problem. So that's the sum law. So now there's also the difference law. The difference law is the same thing. I'm just going to abbreviate it, but it's difference. I'm just going to put a dot, but that means difference law. It's the same thing, except here you're going to have a subtraction. And what happens when you have a subtraction? So instead of adding the two functions, you do the limit of f of x minus the limit of g of x. So that's the sum and difference law. Now we're going to go into another one. It's called the constant multiple law. Now this one's actually the most easiest one. I'll also give you a short example here so you have an understanding of what I mean. So constant is just a value like we talked about, like plus 5, plus 6, that sort of thing. So if you were focusing on the constant multiple law, let's say we have a limit as x goes to a for f of x, but we just don't have an f of x. We also have a c in front of it. That c represents a constant. So if we're given that type of, you can just keep the, if you're given this type, you just put this constant in the front of the limit, and then you can just do the limit of just f of x. You don't need to worry about the constant. You can just keep it to the side. So for example, let's say this was 2 fx, you can just put the 2 on the outside. So it'd be 2 limit fx, or you could leave it in the inside, but to make it easier to solve the problem, you can just take it out so that you have less numbers to work with and less calculations. All right, now we're going to do the product law. So product law is another one. Just like it is, the product means multiplying the two functions. And just like the sum law, you can separate them, except when you're not adding them, you're going to be multiplying them. So let's say we have the limit x as it goes to a, and it's f of x, which is the first function, and then g of x, the second function, and these are being multiplied. Now let's say we want to do the product law for these. You can leave it just like that, or you can separate them for making it easier. So it would be the limit as x goes to a, f of x, times, that's what the dot is for, times the limit as x goes to a, g of x. Sorry, I just wrote it on the top, but it should be to the side because I didn't have space there. Okay, now if we have the product law, that means we must also have the quotient law. Now the quotient law is actually pretty straightforward too. Let's say we're given a numerator and denominator per se, basically a division problem, right? That's what quotients are. So we have the limit as x goes to a, f of x, let's say a function on the top known as f of x, and then a function on the bottom known as g of x. To do this, it's really easy. You just take the limit, you just separate them basically, just like we did for the product rule. So you have the limit of a for f of x on the top, and then you take the limit on the bottom, the limit on the bottom, so same thing. for the quotient rule. So you can separate the limits. You don't have to do them together, but you could do them together. It wouldn't make a difference. But in some situations, it's easier to do this versus doing it as a whole. And you have to remember that this cannot equal 0. Remember, the denominator can never be 0 because if it is, it's undefined. All right, now we're going to go into a little few more and we're almost done. So next one is the power law. Okay, power law is actually pretty straightforward. It's just a power, but a little more easier, makes it easier this by having this law. So limit as x goes to a, and then we have function f of x as it's raised to the power of n, some power n, right? Now, instead of leaving it like this, you don't need to do it just like that. You can basically take the power to the whole limit. So you can do the limit as x goes to a, f of x, and then raise that whole thing to the power n, because what you're usually going to do is just plug in this a value in for x and then to raise that power. So just leaving it like this and then doing it to a power of n would be the same case. Okay, so we talked about the power law. Now we are going to talk about the root law. So the root law is the same case like the power law. That means you can apply the root to the whole thing rather than just a segment. So you have the limit as x goes to a, and then you have n square root f of x. Now let's say I want to make this easier for myself. I can apply the root to the whole thing rather than just that portion. It means the same thing. Sorry, my things today is really bad, my mouse, but that is an arrow and that's an a. So you can apply it to the whole thing. So it'd be the n on the outside and f of x. And something before I continue going further, for the root law and for the previous power law, n is positive. Okay, it cannot be negative. So it has to be positive. Alright, so those are this, and then let's go over some simple ones. So the limit as x goes to a for a constant is just equal to a constant. So let's say we had the limit of a going to 2, then that's just 2. Whatever c is, the constant, that would be your answer. Now let's say the limit as x goes to a and you have x. Obviously that would equal a because you plug in, as when it says x is going to a, you're basically plugging in a for x. That's why it's equal to a. So let's say it was limit as x goes to 2 and we have an x here. Then we plug in 2 for x, which means this would have to be 2 or a. Right? And then the last property I'm going to talk about is direct substitution property. This is the one that is the most important one in all of them. So you must remember this one. Those other ones are kind of come along, kind of like get used to them, meaning in the sense of you do it automatically kind of thing. But this one is the most important one, direct substitution property. That means as the limit x goes to a for f of x, it equals f of a, because when you have this type of situation, you are plugging in a for x. That's why you get f of a. So that is it for limit laws. If you have any questions or any topics or comments, you can put them down below. And if you have any concerns or anything you want me to talk about, please do so. And thank you and goodbye.